All right, in another video, you already saw how to get a correlation using a formula in Excel, and there are other videos to help you see how to get regression outputs using the data analysis toolpack. But in this one, I want to show you how you can assess a relationship between two variables using just a chart, just a scatter plot in Excel. So let's say with that same correlation example, we want to understand the relationship between employee's age and the distance that they travel from home to the office. Now, we already know from the formula that there's not really a correlation here, but had you have chosen to explore this more visually first, you might do this to look to see if there is a relationship. And what we can do is we can select the whole column for age, as well as the whole column from distance from home. That's because in this example, I want to use all the data. And I know that they're paired already, meaning this person on row 2, who's 41 years old, is the person who has a distance from home of 1, meaning 1 mile in this case. So with both of them selected, I can go to Insert, and I can find all of these pre-made chart options, and there just so happens to be one right here for a scatter chart. Now this is going to put each one of those data points as a little bubble on a chart. So it's going to show my person who's on row 2 as a bubble at the age of 41 and at the distance from home of 1. And then each other person is going to get a little bubble in their picture. And it will look, I'm going to use the first scatter here, something like this. So each person in the data set is represented as a single dot in the scatter plot. What you won't see is if there are multiple people in one place. So for example, this particular dot can have potentially a lot of people at that age and distance from home, and you won't gather that from the data. But you can see how that it's scattered across here. And you can see that on the bottom, we have age. Now, age is put on the bottom, the x-axis, because that's the column that I selected first. Whatever column you put in first is going to go on the x, whichever one you put in second is going to go on the y. If you're just doing a correlation, looking to see if there's a relationship between two things, it doesn't matter which one you put in first. But if you're going to do a regression and you want one item to be the independent variable, meaning you think it might predict the dependent variable, well then the independent variable would be your x-axis and your dependent variable would be the y. So in the next videos, you'll see the regression output in which we're using distance from home as the y. So in this case, I did age first as my x, or independent variable, and I did distance from home as my y, or dependent variable. And so this would be an accurate scatter plot for that. Now, just by looking at this picture, I get a fairly good sense for the data. I can see that age tends to start somewhere about 18 years old, which makes sense for many working individuals, and goes a little past 60. I can also see that the distance from home tends to be between 0 miles and upwards of 30 miles. So this gives me a feeling for where the data sits. And I can see that there's not necessarily a clear line jumping out to me from this visual. And that's the idea with a scatter plot. We're looking to see if there's a linear relationship between the data points. And you'd actually get a sense for this if all those dots happen to move around with each other on a line. But sometimes you can't tell just by looking at it. So what you can do with your chart is you can go to Add Chart Element, and you want to add a trend line. Now for a linear relationship, you do want to add a linear line, but we're going to add some extra things on it. So rather than just clicking linear, which you can do, we're going to go to More Trend Line Options. And this is going to let us pick our trend line. We want linear, and it's going to let us turn on a couple other items. So I'm going to ask it to turn on the equation on the chart. So I've checked this box, and I'm going to tell it to display the r-squared. Now this equation and r-squared are actually the same values and data points that you need to figure out whether or not you have a regression equation that you can work with. Again, there's a video on how to create a regression output and read the values there, but this will give you many of the same data inputs that you need for a simple linear regression. Now, when I clicked them, all the info ended up hidden there in the bubbles. It's a little hard to see. I can tell that they're there, but I kind of need to just move it around. So I've selected the equation and just slid it up to the top where I can see it. And now you can see that my equation here is y, that's the dependent variable, distance from home, equals negative 0.0015 times the independent variable, or age, meaning that for each additional year of age, we would expect the distance from home to go down by 0.0015 miles. That's not a big change at all. There might not be much of a relationship. And this plus 9.2478, that is what we call the intercept. It just means where should we draw this line? So this equation is how Excel also makes a line that is on the picture. Now again, I clicked the linear line. What you're not seeing right now is there is actually a line here. It can be a little confusing sometimes with Excel, especially in this case. It decided to do blue dots with a blue dotted line. Why? I don't know. But you can go over to the format area and you can change the color of the line. So I know the line's here. I've selected it. And just to make it easier to see, I'm going to change the color to orange. I'm going to make it a lot wider, and maybe I will even turn it into a straight line so that we can see it better. So we have equation for a line, and we can see that the line is pretty much flat. That's because there's not really a correlation here. If I had done the scatter plot, I would know, probably not a relationship, not worth going further and doing more with this one. I would also know that because I can look at the R-square. Now the R-square is an indicator of how much variance does your X variable predict about the Y variable. And you can talk about it as a percentage. So in this case, it's about a 0% variance explained. So again, not a very good model. We're not surprised because we discovered that in our correlation, but this is how we would find that out in a graph form. And it can be a very quick way to show your relationships and to talk about not only how movement in one variable, meaning each additional year of age, affects distance from home, as shown by the equation, but also to talk about the strength of this regression through the R-squared. I do recommend you check out the video on how to interpret and to do a regression in Excel's data analysis tool pack, because you'll learn some additional things about understanding how to look at a model and how to read the impacts of the different variables.